Okay, we're going to start. Brief review from yesterday. We talked about square root of 25. We talked about what it means to be a square root, right?
Yeah.
That square root means it's, right, what number times itself. And we also talked about how to do this on the calculator. So square root of 25 was going to be
5.
5, because 5 times 5 is 25.
What?
Now, we also talked about the fact that this square root symbol is called a radical. So if we talk, it's a radical. And then we also talked about the number under the square root symbol. So in this case, the 25 is called a radicand. Okay? Yes?
Isn't that like a new thing for second semester? Because I've never heard about radic.
It's just a vocabulary word. And maybe it didn't get introduced. It's just a vocabulary word. No big deal. Honestly, I'm not sure you'll see it in the homework or anything. So, now, examples. We talked about these. Square root of 64 was what class?
8.
8. Because 8 times 8 is 64. Square root of 121 was 11. Because 11 times 11 is 121. Square root of 81 over 400.
9 over 20.
9 over 20. Remember what I said. I know fractions stress some of you. Now let me rephrase this. I don't know you guys well enough yet to know fractions stress you, but what I know is a lot of math students, fractions stress them.
Wait, math?
Math.
Oh, I thought you said math.
A lot of math students. So here's what I suggested yesterday, is think about it as the square root of 81 and the square root of 400. Square root of 81 is 9. Square root of 400 is 20. And 9 over 20. If you forget how to do a square root on the calculator today, ask me and I can show you individually. Square root of the decimal 3600.
0.6. You just think as that. Oops.
Hey, I did
Yeah.
that yesterday.
And yes, you can think of it as 36 over 100 and do it that way. Okay. You can also just think, oh, hey, square root of 36 is 6. There's 2 decimal places here, so when I multiply it back together, I just need 1. Okay, so that was the top part of the notes that we spent some time on. What we were working on at the end of class was being able to classify numbers. We talked about rational numbers. Any number you can write in the form of a fraction. Now, what I said, one way I said it was non-messy decimals. And probably a better way to say non-messy decimals, decimals that do not end, that end or repeat. Okay? So decimals, I'm going to scoot that back some. Decimals that end or repeat. Your notes are with Chloe.
I knew you were going to say that.
I just realized that.
I knew it.
You just need to start leaving them in my classroom, probably.
That's what I was going to ask you if I could do it.
Yeah, you probably may do that in the future for this exact reason. But you're writing them down.
Yeah.
Good, thank you. Okay, natural numbers. We talked about natural numbers being what you learned back in kindergarten. 1, 2, 3, 4, 5, 6. Okay. Whole numbers,
0, 1, 3.
you add 0. Integers, you add
3.
negatives. Irrational numbers are numbers that cannot be a fraction. And then I like to mention that they're the decimal that does not repeat or end. This is where yesterday I believe I used the phrase messy decimals.
Smiley face.
Okay. Messy decimals, as in if you have a decimal, we talked about pi, didn't we?
Yeah.
What is pi?
Endless.
3.1.
Yeah, something like
We
that.
use 3.14, but you also know that it's
Never ends.
Never ends.
3.14, yada, 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 yada.
That keeps going on forever.
A bunch of other numbers.
If you look it up, there's
Okay.
a list and it goes on forever.
And then lastly, real numbers, all rational and irrational numbers. So all of these numbers we just talked about are real. Now, what we're going to do on the bottom part, on the examples. Okay. I don't have the directions,
Three
but
times 3.
basically we're going to talk about, we're not finding these, we're going to name which groups of numbers they belong to.
But what are you?
Hold on, just let me teach for a moment, okay? I'll let you talk here in a moment, but hold on a moment. So we're going to name I don't want to say name, I'll say name the groups of numbers each belongs to. Okay, so we're going to name the groups of numbers each belongs to. As we do that, okay, on all of these, I'm going to ask you, is the number rational? I'm going to ask you if the number is rational or irrational. Actually, I'm going to take that question mark off. And then I'm going to ask you, is the number a natural number, a whole number, an integer? That's what I'm going to ask you. Okay? So, every number we talk about will either be rational or irrational. Remember, rational, it can be made a fraction.
So that.
Okay? Irrational, it cannot be a fraction. Now, as we talk about this, let's back up for a moment. What is the square root of 9?
3. That's what I was saying.
Does 3 make sense?
Yeah.
Because 3 times 3 is 9. Now, okay, square root of 9 is 3. Can 3 be written as a fraction?
3 over 1.
Yeah. How do you take any whole number and make it a fraction? You put it over 1. So that right there is 3 over 1. So square root of 9 is equal to 3 over 1. Is it rational or irrational?
Rational.
Why rational, Ryland?
Because irrational is a fraction.
Didn't I just write this as a fraction? Yeah, I just wrote this as a fraction. So it's rational. If it's rational, it cannot be irrational. It's one or the other, not both. Now,
Like the homework last night? It had
hold on,
rational
hold on.
And rational together.
Okay, we're not, just hold on, okay. Focus, I need to focus on this so we can get to homework time for everyone else that hasn't done the homework yet. Now I want to know, is the square root of 9 a natural number? Which, keep in mind, what does square root of 9 equal?
3.
It's 3. So go back up here. Natural numbers, those were your kindergarten numbers, right?
Yeah.
Is 3 a number you knew in kindergarten?
Yeah.
Should be. So, is this a natural number? Is this a natural number?
Yes.
Yes. Okay.
Also a whole number too.
Is it in my whole number list?
Yes.
Yes. So it's a whole number.
We used to not be able to say.
Is it an integer?
Yeah.
Yes.
Because integer is your whole numbers, and they're negative counterparts. So the square root of 9 actually is all 4 of those.
That's nice.
It's also technically a real number. because everything we talked about is a
Number.
real number. Okay. Next one. Same questions. We're going to start off here in a moment. Is it rational or irrational? And then after we decide that, we're going to ask natural, whole, and integer. Okay.
Rational,
Okay, so 3/10. What do you know about 3/10?
It's a number.
It's a number.
It's a fraction.
Okay. Important to deciding rational versus irrational. We need to know,
Can it,
is it not a fraction or is it a fraction?
I think it's not a fraction.
Or repeat.
Don't waste my time here. I'm trying to get you guys work time so you don't have homework, okay?
I'm sorry.
This is where I need you guys on this task, not on other topics, and focus with me, okay? So 3/10 is
Rational.
rational because it's a fraction. If it's rational, what's that mean about irrational?
It's not. I don't know. It's crossed out.
It's not, because it's either one
Or the other.
or the other. It can't ever be both. Now, the fraction 3/10. Does that fall into my natural number category? Is that one of those numbers you learned in kindergarten?
No.
0, 1, 2, 3, 4, 5, 6,
Yeah.
so on and so forth?
No.
A fraction?
Wait. Oh.
Do you see any fractions listed in natural numbers?
No.
I'm lost.
Okay. Stop and listen. Do me a favor, guys. Don't just blurt stuff out. Stop and listen. 3/10 is a fraction. Do my natural numbers include just random fractions?
No.
No. Do you see anything like 3/10 in this list?
No.
I only see 1, 2, 3, 4, 5, and then ... means
More.
6, 7, 8, 9, 10, 11, 12, forever, right? So is it natural? No. Natural does not include fractions. Is it a whole number?
Nope.
Nope.
No. Do I see fractions in that list? No. Is it an integer?
Nope.
Nope.
No. So the only thing this one is
It's irrational.
rational. And, of course, all of them are technically real. Okay? Next example. Let me write out my options here real quick. We're going to ask rational or irrational in a moment. Don't answer me yet. We're going to ask if it's natural. We're going to ask if it's a whole number. And we're going to ask if it's an integer. Now, before we do that, negative 0.45.
That's on none of them.
Well, here's the deal. This has to be rational or irrational. So we have to talk about, can this be written as a fraction? And this is where we kind of have to talk about, like over here, could square root of 9 be a fraction?
Mhm.
Yeah, because we could write it as 3/1. Now, I don't know if you know the answer to this, but years ago, you were taught how to read this decimal correctly. When I say negative 0.45, I'm not being a good math teacher. Because this is negative 45 what?
Over 1.
Not over 1.
Over 2.
What place value is this? Tenths? What's the 5 in? Hundredths.
So
The decimal negative 0.45 is the fraction negative 45 100ths.
So it's 4/500.
So that decimal read as 45 hundredths is that fraction 45 over 100.
Wait. So any like one of those that have like a negative, is it always? Or is
It could be either way.
It doesn't matter that it's a negative. It's just as long as there's a set number of decimal places. So each decimal place represents a 0.
Okay.
So if there was only just 4, it'd be 4 over 10. The 4 5 is 45 over 100.
Okay.
If we added another number after 4 5, it'd be over 1,000.
Okay.
Add another one.
Why 1,000?
Okay? Each place value represents 10 there.
Okay.
Now, Rational?
Yeah.
Irrational.
Rational.
We know it's rational because I wrote it as a fraction.
She's quiet.
Okay. Natural. Does negative 45 over 100 fit in this 1, 2, 3, 4, 5 business? Nope. Does it fit in the whole number 0, 1, 2, 3, 4, 5? No.
In it.
Does it fit in the integers?
Yeah. Nope.
Fractions don't fit in any of those unless they can be reduced to those.
Yeah.
So that one's just rational. Okay. One more.
Your classroom's cold.
Now, start thinking about the square root of 12. You might want to grab a calculator. Okay. So, we talked about yesterday how to do
Just kidding.
square roots.
I forgot how to do it because I'm not dumb.
Okay, listen. We talked about yesterday how to do a square root on the calculator. And in this case, like earlier, square root of 9, we knew that was 3. Okay, because we could figure out 3 times 3 is 9. Now, square root of 12. That's one you probably need to put in the calculator.
Okay, so I did that, but it says it air.
Okay, you did do it right then.
Can you confirm how to do it again?
Okay, hold on. How about you watch the screen up here when it comes up?
That's a big screen.
Okay, so I helped you guys with this yesterday, but let's review. First of all, I'm going to hit
The second button,
the second button.
which I've hit 100 times.
Okay, so we hit the second, just hit it once though.
Oh, once.
And then right down here above x squared, you see where it says square root?
Yeah.
So I'm going to hit the x squared button.
Wait a second.
And then it has a square root with a parenthesis. And now you can type 12.
Hold on.
1.23075506. Oh, it goes on forever.
Oh, it's 5. I got 5.779557.
Okay, hold on. Go with mine up here.
Okay.
Okay, you hit something wrong there.
3.4, yeah, that's fine.
Okay, now, here's the deal. We have this 3.464, and does that decimal end when my calculator screen ends?
No.
No.
It goes on forever.
It goes on forever and ever and ever. Is it repeating?
No.
No.
Different numbers.
It does not end, and it does not repeat.
Well, it does kind of what it's 4.6.
It does not end, it does not repeat. What category does that fit in? Rational or irrational?
Irrational.
Irrational, a decimal that does not repeat or end. So what are we going to say about this one?
Irrational.
Irrational. If it's irrational, it's not rational because it's one or the other. But a big, long, messy decimal like that cannot be a fraction. Now, here's the deal. Is this 3.464101, whatever, is it going to fit into natural, whole, or integer?
Nope.
No. And if it's irrational, I automatically know it can't. Okay? Okay. Your homework that I want you guys to get working on right now is lesson 1.3 in Math Excel. If you don't have a 100 on it, you should be working on it.
Got it.
If you did get it done, sit quietly and let the rest work. And if you need help with the calculator, I'll help with that too.